Hello everybody, we will be covering next progress on repair of HP 3458A, and also I get the new kit 3245A, which is universal generator. So we'll take a look inside of that beast and try to repair it. So it will be a full teardown and we'll see what's inside and what boards are used and what methods are used to generate those 6 decade precision voltages. Okay, and here is my meter, which is currently dead and waiting for the parts. So I'll show you what's the problem. The high suspect is AD converter, which is having errors if I try to use it with NPLC speeds faster than slower than 0005. So it's giving errors like this one, system error. Sorry it's upside down, but I already had a video on this before. Sometimes it's able to take couple samples, sometimes not. So today we will try to do the ultimate repair by using the stuff in those boxes. So it will be a tear down. And let's see what's inside. I'll take this big beast down for a little. And we will start from the small one. Don't get confused by Keysight label on the box. It's not shipped from the Keysight. But nevertheless, A1 analog board for the 3458A, which is not working, and you will see in a moment why it is so. That's the board. And obviously it have a little bit of a problem. There is a nice hole, and on the back side. So we will be trying to repair this by some radical extreme reworking. Rest of the board seem pretty intact. Oh, I speak too quick. There is a burnt resistor in here, or it was a capacitor. I think it was a capacitor. But this is not what is most interesting right now. we will go back to this board later. Let's see what's in the second box. This is way more valuable to me, since this is a functional board which I'll use instead of my faulty one, and to see if I can repair that pesky convergence error. Sorry, I cannot see it. I'm holding the board by corners, so I will not put the dirt or oil on sensitive components. So let's swap the board and try if this one fixes the issue. So here is the board. This is analog to digital converter for 3458A. So it have custom chips, and if you have a problem with any of those, it will be pretty much useless. And the date codes on it are 1995, 1995. So this is about 20-year-old board. Well, let's hope it works. And let's do the board replacement and see what we can get. And I'll turn this one upside down as well. During the previous attempt of debugging the issue on my board, I already replaced a lot of op-amps, comparators, and some logic chips, but it didn't help. So I spent about 50 hours trying to fix it without much luck. Alright, here is the old board. I'll just leave it aside for now. Boy. Okay. Yeah, back. electrical interface. And the shield. Okay, now everything is in place. Let's power this beast on and see what it does. Okay, we're back in business. This is the usual calibration error. Let's run self-test. This was failing right about this moment before, and now as you can see it's working fine. Well, this is great. I think I'll put the covers back on the meter and then... Oh, self-test failed. What was the problem? Level duct convergence. This one is interesting. Oh, I know. This is because I have few parts removed on the A3 board, so I have to fix that back again. Okay, let's try 10. No problems on the voltages. Ohms. Okay. I'll not bother with the AC board at this moment. I'll fix that later. And the issue is because I have this buffer in here removed. But it's only on the AC path, so that's why DC voltage is working fine now. And so let's see if it can pass. It's already 2 AM in here, so shows you how easy you can get carried away messing with all these crazy instruments. Okay. Now let's try 10K. For 10K, I need to measure it first. Alright, this is the resistor which I'll use. It's 10 kilo ohm, Vishai VHP 202 ZT. So this is incorrect reading, and it should be, let me show you what it should be. Going down because the resistor was a little bit warmer. Let's open this. Let's test. Comp.
So far so good. Still running. Hundred milliamps.
1 amp. For the resistance calibration, I should be using 4-wire connection to the resistor, but now, just to see if everything working, I just shorted sense wires to force wires directly on the DMM terminals. Of course, when I'll be calibrating for the actual accuracy, then I'll do the proper connection. And you're probably wondering what was the issue with the level, the convergence. It was this bad guy, which is comparator replaced on the A2 board. So that was dodgy comparator. Alright, over there. Calibrating current, 100 nanoamps.